Hey everyone, and welcome. Today, we're going to tackle a really classic coding challenge, removing duplicate numbers from a sorted array. Now it sounds simple, but the solution is so clever and so efficient. Let's dive right in.
Okay, so picture this. Someone hands you this array of numbers. It's a total jumble, right? You can spot the duplicates, sure, but they're all over the place. Finding them all feels, well, kind of messy.
So I'm asking you, how would you go about finding just the unique numbers? You might think about using a separate list to keep track of everything you've seen, or maybe sorting it first. It just doesn't feel very clean, does it?
But what if you were given this instead? It's the same numbers, but look, now they're sorted. This one little detail, this single property, changes everything. It is the key that unlocks a beautifully simple and really powerful strategy. So, let's get official. Here's our mission. We're not just finding duplicates. We have to remove them, and we have to do it under a very specific and very important constraint.
The problem asks us to remove these duplicates in place. Now that's a key phrase. It means we cannot create a new array. We have to modify the original one, right there on the spot, so that all the unique numbers are gathered up at the beginning.
Let's look at a couple of examples to make this super clear. If you get 1, 1, 2, the function needs to return k equals 2, and the array itself gets changed so its first two spots are 1 and 2. We literally don't care what's in the rest of the array. For this bigger one here, the output is k equals 5, and the first 5 elements become 0, 1, 2, 3, 4. So k is just the final count of our unique items.
You know, like any good puzzle, the solution is hiding in plain sight, right inside the clues of the problem statement. We just need to know what to look for.
So the first big clue is that term in place. This is a huge constraint. It's telling us we can't cheat by just making a brand new, clean array. Nope, we have to work with what we've got, which is all about being efficient with memory. And this brings us to the most powerful clue of them all, the game changer, the fact that the array is sorted. Why is this so incredibly important? Because it means all the duplicate numbers are guaranteed to be right next to each other. They're all huddled together. This single insight is what our whole strategy is going to be built on.
Okay, so with those clues in our pocket, we can unleash a really elegant strategy called the two-pointer technique. I want you to think of it like we're deploying a two-person team to tackle this problem with maximum efficiency.
Let's give our pointers some names to make this easier. First, we have the builder. Think of this pointer as building our final clean array from left to right. It only moves when we found a new, unique number to add. Then we have the scout. The scout is the fast one. Its job is to race ahead, scan the rest of the array, and find the next unique number for our builder. Now, the best way to really get this is just to see it in action. So let's walk through that bigger example from before and watch how our builder and scout work together as a team.
All right, here's our starting line. The builder, f, starts at index 0. We can say this first element is automatically our first unique item. The scout, s, starts one step ahead at index 1, ready to begin its search.
Okay, first check. The scout sees the value 0. It compares that to what the builder is looking at, which is also 0. It's a match. That means we found a duplicate. So the builder stays exactly where it is. The scout's job is to find something different, so it just moves one step forward to keep looking. Aha! Now the scout is at a 1. It compares that to the builder's value of 0. They're different. Ding, ding, ding. This is the signal. The scout has found our next unique number. So the builder springs into action. First, it moves one step forward to index 1, and then it copies the scout's value into that new position. Our array is now 0, 1, 0, ... See that?
Now watch the scout. It just keeps moving, skipping right over all the other ones. Why? Well, because they're all duplicates of what the builder is currently on. The scout's mission is to find something new. And here it is, the number 2. And the pattern just repeats itself. The scout found something new, the number 2. So the builder moves up one spot and copies that value over. Our array has now been modified to 0, 1, 2. This is that in-place modification we were talking about. We're literally overwriting the old duplicates that we don't need anymore.
This whole process continues all the way to the end. The scout finds a 3, the builder moves and copies it. The scout finds a 4, the builder moves and copies that. Once the scout runs right off the end of the array, our work is done. The front of our array now holds 0, 1, 2, 3, 4, all the unique elements perfectly in order, and our builder is now resting at index 4.
So now that we've got the logic down pat,
Let's see how this visual strategy translates into just a few lines of surprisingly simple code. It's pretty amazing.
The core of the code is really just a simple if-else statement. Inside a loop, we check, is the builder's number the same as the scout's number? If it is, that's a duplicate. We do nothing but move the scout forward. Else, if they're different, that means the scout found a new unique number. So we move the builder forward one spot, and then we copy the scout's value into the builder's new position. That's it. That's the whole algorithm.
So once that loop is all done, what's our final answer k? It's super simple. Our builder pointer, f, is sitting on the index of the very last unique element. And since array indices start at 0, the total count of unique items is always going to be f plus 1. In our example, f ended at index 4, so we have 5 unique elements. Easy as that.
So let's just take a step back. What's the big takeaway from all of this? We successfully completed our mission. For our big example, we found that k, the number of unique elements, is 5. And we did it efficiently, we did it in place, and we used 0 extra memory. How? All because we took advantage of that one critical clue. The array was sorted. That's the power of picking the right strategy.
And that leaves us with a final thought to chew on. This whole idea of a scout and builder pointer team is an incredibly powerful pattern. It's not just for removing duplicates. So where else do you think you could apply this technique? One pointer exploring ahead while another one builds a result. It is a fantastic tool to have in your problem-solving toolkit.